approach. The magic here is a little device called a planetary gear set. It's an incredible piece of engineering that lets a computer continuously blend the power sources. It can act like a series hybrid in the city, a parallel on the highway, or anything in between, constantly optimizing for the best possible efficiency.
The result? Maximum efficiency, pretty much everywhere you drive. So what's the catch? Well, all that genius comes with the highest level of mechanical and software complexity. And you guessed it, that makes it the most expensive to build. Okay, so we've covered the three main layouts. But now let's look at this from a totally different angle. Because it's not just about how the parts are connected, it's also about the degree of hybridization. How much does the electric side of things actually do?
You can really think of it as a spectrum. On one end, you have mild hybrids, which basically just give the engine a little electric boost. In the middle, you have full hybrids. These can actually drive for short distances on electricity alone. And then, way over on the far end, you have plug-in hybrids, which bring the power grid itself into the equation. And you can see the relationship pretty clearly here. The main takeaway is that as the battery gets bigger, the car's ability to run on pure electricity goes up. It all leads to the plug-in hybrid, whose large battery can be charged from a wall outlet, giving you a serious amount of gas-free driving, often more than enough for a whole day's commute. So far, we've pretty much kept our feet on the ground talking about cars. But now we're going to take this whole conversation to a much, much higher altitude, because these same principles are starting a revolution somewhere else entirely. That's right. That same brilliant compromise, combining an engine's endurance with a motor's quiet efficiency, is now being applied to aviation. We're talking everything from unmanned drones to urban air taxis, and maybe even the commercial jets of the future. But here's the interesting thing. The goals in the air are a little bit different. With cars, it's all about getting better miles per gallon in traffic. With aircraft, hybrid systems are used for other critical things, like flying farther, being much quieter, and helping the engine perform better in the thin air at high altitudes. And for drones, both military and commercial, this is an absolute game changer. It means they can fly much longer surveillance missions. It gives them a backup if one power system fails, which is huge for safety.